All right, so we said that in chemistry, the way that we're going to count things is by weighing them. And instead of talking about individual molecules, we talk about moles. So for example, no one's ever going to say, hey, get me 1.85 times 10 to the 24 atoms of copper, right? We rarely ever talk about individual atoms. What they're going to say instead is the number of moles. And being able to convert from moles to atoms or molecules should be very simple. Just use your conversion factor. Right? Which one of these sentences is easier to say? Get me 1.85 times 10 to the 24th atoms of copper, or get me 3.07 moles of copper, right? The moles are just easier to say, and that's why we want to use them. So similar to our nail analogy, in order to be able to count something by weighing, we need to know how much an individual one weighs or how much a group of them weigh, right? So we always count by moles. So we want to know how much 1 mole of something weighs. So need to know how much 1 mole of, in this case, copper weighs, right? Whatever you're interested in, you need to know how much 1 mole of it weighs. That way you can weigh out as many moles as you wanted. Here's just a little picture to just emphasize how big a mole is. On the left side, you have the little picture of Earth, right? There's us on Earth. And on the outside, or on the other side, you have 1 mole of basketballs, right? And you can see it's the same size as Earth, right? So 1 mole is just a huge, huge number. On the right side, we've got 1 mole of each substance. Right, so you've got 1 mole of zinc, 1 mole of carbon, 1 mole of magnesium. And on the left side, you have 1 mole of basketballs, right? Each one of these have the same number of things by counting. They all have 6.022 times 10 to the 23rd things, right? Whether those be atoms or basketball. And you can just see the difference in size and mass between an atom and a basketball, and that makes sense, right? So anyways, how do we know how much 1 mole of each thing weighs? Well, we use our handy dandy periodic table. So for example, our periodic table, or this little picture indicates that 1 mole of zinc weighs 65.4 grams. If we take a look at our periodic table and we zoom in on zinc, you can see that number right under it, 65.4, right? You round up a little bit. So you can see that our molar mass, as it's known, is shown on the periodic table. And then same thing with every other element, right? So here's copper, right? 1 mole of copper is 63.5 grams. How did they know that was 1 mole of copper? Well, they looked at their periodic table and weighed out that much, right? So the periodic table contains the molar mass. So for copper, remember that we counted this already. We said it was 63.546 AMU, atomic mass units. Well, these atomic mass units are the same as the molar mass. So it weighs out 63.546 grams per mole, right? And again, this is known as the molar mass, all often abbreviated as double capital M. And what this means is that if you have 1 mole, or if you want 1 mole, then you should weigh out 63.546 grams, right? This many grams is equal to this many moles. Just like we had this many grams was equal to 1 nail. Now we're saying this many grams of whatever element you're interested in is equal to 1 mole of that. So back to our original question, someone asks you to weigh out 3.07 moles of copper, that should be relatively easy to do. You would just take 3.07 moles and then use your conversion factor, which is just the molar mass, right? Copper weighs 63.546 grams per mole. Moles is down on the bottom. That way this can cancel out, right? If you're wondering what the number for the mole is, it's 1, right? 1 mole. Anytime that you have a conversion factor that is a unit over top of a unit, the number corresponds to the first unit, and the second unit, in this case moles, just gets a 1 in front of it, right? Grams per mole, 63.546 grams per 1 mole. And then you just go ahead and do the math, and then you have 195 grams of copper, right? Relatively simple. You can do other kinds of questions. So you have 0.72 kilograms of copper. How many moles? Right? Maybe you're going to react this copper with something else, and so you need to know how many moles of copper. That way you can get the right ratio. So you'd start off with the thing that's not your conversion unit, the 0.72 kilograms. We note that molar mass is always in grams per mole, so we got to change our kilograms to grams. For every 1 kilogram, there's 1,000 grams. After that, we simply use the molar mass. This time the molar mass is going to go down on the bottom, or the numerical value is going to go down on the bottom. That way the grams cancel out with one another, right? Kilogram with kilogram, gram with gram, and now we're left with moles. And you could ask yourself, or you could go even further. Remember that moles and atoms, they're the same concept. So you could just ask yourself, how many atoms of copper? And you would do the same process, right? Start off with your 0.72 kilograms. Through the magic of technology, I'll just copy this over. Right, now that the unit that we're at is moles, we can just keep going and say, hey, 1 mole is equal to 6.022 times 10 to the 23rd. And then you get an answer of 6.8 times 10 to the 24th atoms of copper. Note that these two values, 11 moles and the 6.8 times 10 to the 24th, have the same info. The moles is just easier to use, it's easier to say, and so that's what we stick with.